Okay, next up, quadratic substitution. So whenever we're dealing with quadratics, we just have to be a bit more picky about which variable we rearrange for, because I can't eliminate the x's because there's an x squared and an x involved. So I have to pick one of these two equations and solve for y. Really doesn't seem to matter which one. I'm going to pick this guy. So 3x squared minus x minus 2 equals y. So my first step is to rearrange one of the two equations for y. My next step is to plug that in there. So this is the second step. So 6x squared plus 4x minus, notice I'm putting a bracket there, this whole thing. The reason I'm putting the bracket, and it's a very common mistake, is that if you're subtracting y and this equals y, you need to distribute that negative. So what we're going to do now is distribute that negative and collect like terms. So minus 3x squared plus x plus 2 equals 4. So I have a 3x squared, I have a 5x, and I'm going to bring this 4 on the other side, so it's going to be negative 4, minus 2 equals 0. So when you have quadratic, the method is the same. Rearrange one of them for y, plug that in the other equation. Now we need to solve for x. We have a quadratic here, and it's not an easy factoring, so we're going to have to use the box method. So we're looking for two numbers that multiply to be negative 6 and add to be 5. So 6 and negative 1 I think are going to work. So I'm going to build my box here, 3x squared minus 2, 6x, and minus 1x. So then what I do is I factor at my greatest common factor. So this is a 3x minus 1. So this is going to be an x plus 2. And then I just double check to make sure that the box works. So I end up with 3x minus 1 and x plus 2. So now I still need to solve for x. So I'm just going to come over here. And so I end up, I take each bracket, set it equal to 0, and solve for x. So I get x equals a third and x equals negative 2. So that's the third step there, is to solve for x. Now I need to solve for y. Remember, you always will have an equation here already set equal to y, and I need to do it for two separate things. So when x equals a third, y equals 3 times a third squared minus a third minus 2. And this one ends up being negative 2. So I get a point at a third and negative 2. That's one of my answers. And then I need to do that again for negative 2. So when x equals negative 2, y equals 3 times negative 2 squared minus 2 minus 2, and that one ends up being 8. So I have an answer at negative 2, 8. And I would always check. So I would always take those answers and plug it back in the original equations to make sure they work. So that is doing not linear quadratic, quadratic with substitution.